So this one's going to be mostly triangle geometry that you're going to need to do to figure out the numbers. If we were to do this one here is 90. So 90 plus 29 is 119. That means there's going to be 61 degrees up in that corner. And then if we figured out it's 90 on one side, it's got to be 90 here also. So if I know 58 degrees has already been used, then to make 90 degrees on the other side, I'm going to need 32. Okay. And I can keep going. If I added up 32 and 119, that's 151, I think. Yeah, okay, 151. And I need to get from 151 to 180 to complete the triangle. So 29 is here. And if I was to come up with, this is a straight line, so 119 plus something has to be the 180 degrees that make up a line. So that would give me 61. And 61 and 58, that's going to be 119. And 119 plus something has to give me 180 degrees to give me the last angle. 71? 61? Okay, so now that we have all the angles, it says identify any equal segments. So let's try to do that here. Anybody see an equal segments right away that maybe we can identify?
PS and PQ.
PS, okay, so PS, which goes from here to here. And what was the other one?
PQ.
PQ?
Yeah.
This one here?
Yeah.
Okay, how? How do you know that?
Because the two angles are the same.
Yeah, so this is a triangle with equal angles. Equal angles mean equal sides. So yeah, I would agree with you. PQ is equal to PS. So this is an isosceles triangle. Okay, what other angles do we know are, what other sides do we know are equal length?
RT and RS.
RT and RS, same reason. Okay, so it's RS, RT, and that's an isosceles triangle. Okay, we've got to find one more. RQ and RS. You're correct. How come? Split down the middle. RQ and RS. So, how do you know that's been split down the middle? Yeah, so the angle bisector. Something along those lines would go into your explanation. It bisects the angle, so if you have the same angle here, same angle there. What else, though, might we be able to say? Okay, well, I'm going to put some more pictures on here. If this is equal to this length here, and this length equals this length, how many things do you need to show the two triangles are equal? Do you remember doing this? Okay, if you have two sides, that's not quite enough.
On an angle?
On an angle, that'll work, right? Two sides and an angle, then you can show the triangles are the same. So right now I've got two sides, and we've got these angles in here. So, oh sorry, that's not the sides that we have. It's that's the side we're looking for. It's this side is the same, right? It's the same piece. It's literally the same side of the triangle. So because this is same side here and same sides there, that means with these angles, I know these sides must be equal too. So either way, you could make that into your work that into your answer. You could use the same triangles. So I could say triangle PQR equals triangle P. Whoops, that's not a P. P. Let's see here. P. What was it? RS.
Yeah.
And that was by side, angle, side. Okay, so last one. Find the measure of each angle. Identify any parallel segments, how you know.
Okay, well D has to be.
Okay, so picture's a little bigger there, so it makes it easier for me to write on it. We've got to find the angles and look for the pairs of parallel line segments. Okay, so let's start then by trying to fill in the angles. we can use isosceles triangles. That gives me 70. That's 140 total, so 40 more gives me the 180. If that's 90 degrees there, it must be 90 degrees there as well. And this is another isosceles triangle, so that means it's got to be equal angles. So that's 180 total. I've used 90. So 180 total, I've used 90, and I have to give it between two equal angles. So each angle in here is 45 degrees. Jeez, good thing I blew it up because I'm really not, there we go, 45 and 45. Okay, if I keep working my way along, let's see, what else can I come up with here? So if this is 90, are we stuck? Is there anything else we can come up with?
BCG.
BCG, how do you get BCG?
No, I meant CBG.
Oh, C, so CBG.
Yeah.
Okay, how did you do that?
180 minus 70 minus 45.
Right, so there's a straight line here, 180, goes the whole way, so what did you come up with?
65.
65. Okay, so it's got all three angles here, 1, 2, 3, have to add up to 180. Okay, so then that means we can get another one in the corner. This angle here, if I add 65 plus 90 degrees is 155, so there should be 25 degrees, will get me up to 180, so finish that triangle.
EDC.
How do you get EDC?
360 minus the thing.
Got 200.
Yeah. So what was left? 110?
110.
Okay. So that one again, if you had a four-sided figure, if you add up the angles, you should get 360. Okay. So what's parallel and how do we know? Can anyone figure out some parallel sides? Sure, Eamon. ED and ABC. Okay, how did you get that? It just looks parallel. Yeah. Okay. Fair enough. Can anybody think of? Let me see. You're. It looks like you're correct there. I'm just trying to think. How could we?
Oh yeah.
The angles in the interior to 180.
The angles.
It's 70 plus 110 equals 180.
70 plus 110 equals to 180.
Like
So-
a C angle.
Oh, I see. So right here, 70 plus 110 adds up to 180. So if they add up to 180 and they're on the same side of the traversal, that's a C angle, which means C angles have parallel lines. Okay, so that's what you're going to need to do to find the parallel segments or to give your reasons here. You're going to need to work those letters backwards because the three letters I gave you, F, C, and Z, all have parallel sides. So the first one, AC is parallel to ED. And this was by, let's see here, same side of the traversal. So we'll say that's a C angle. What other sides are parallel? HB and DC. Okay, so this one here and DC, which is the end one here. Okay, so how did you get that?
HBC is 110 and BC is...
Right, so these two here add up to 110. 110 plus 70 is the 180, so again we end up at the same HB, must be parallel to CD, and that's the same reason, it's a C angle. Okay. Same side of the traversal. They add up to 180, they must be parallel sides. Okay, last pair. What's the last pair of parallel sides? AH and BG. Okay, so from here to here, how do you know they're parallel?
No, they're not parallel.
Say again?
It's like an F angle in the
It's an F angle.
But they're not because it's 90.
It's not, it looks like it, but that's 85 and 90. So yeah, unfortunately it's close, but not quite the same. What else might be parallel in there?
So hard.
since I can't find any other side, I think that would be their intention, would be to say that AB is parallel to ED, or that BC
Or just go AC.
is parallel. That's what we've already done, right?
Oh,
So that one right there. Same reasons, same pieces, right?
it's cheap.
So yeah, it's kind of cheap that we did it that way. But anyways, I can't find another side, so that's what I figure I would have to have come up with for my answer.